we've got our friend, Professor David Hyland from Xavier University. He's going to be discussing visualizing performance data with R. So let me get Dave dialed in here. Hey, Dave, good to see you. Oh, hold on, you're muted. Get you unmuted.
I think I got it.
There you go.
All right.
Hey, Dave.
Hey, well, I love the
Hey.
stuff that just when I just caught the tail end. They've got some good college stuff too. So I'm all about college baseball data, and we definitely pull some of their data, and it's fun watching the stuff they do. What I'm going to do first, I want to thank Scott and the SABR guys. I think this is a great organization, and their focus on trying to develop students and so on is fantastic. I love participating in this every year. One of the things that I found with these sessions is, there's a whole bunch of you on right now, and I'm going to talk about visualizing data, and I'm going to be the right level for about one person, right? I'm going to be too fast for some people. I'm going to be too slow for some people. So what I'm going to do is, try to give you a couple different ways to go about it. What I kind of envision, you've been going at this for a while now this morning. I envision this as kind of can we get you guys doing some stuff? So if you have R and R Studio installed, I would try to work along with me because I'm going to try to just build out some programs to visualizing. If you don't have them, I'm posting the links down here below to download R and R Studio. So you download R first, and then you download R Studio, and you can work along with me. Or the way they do things on the SABR Analytics certificate, which I strongly recommend, is to log into the cloud-based R Studio, right? So what I'm going to try to do today is give you, some examples of using baseball data to create graphs. I think one of the things, the more I do this kind of stuff, the more I realize how visual people are. And we can present tables and we can present data, but if I can provide things in a visual way, and I think it's maybe even more so for athletes and people who have had athletes. I mean, hand-eye coordination. I mean, I don't know. It's a theory, but anyway. The other thing I'm going to give here for you is I've got my R code. So if you're already versed in R, you could pull that up. I won't go exactly along with it, but it'll give you an idea so you can work along with it. So a bunch of different ways that you can work along with me. All right, and let's do this. Let's shift gears a little bit. Just kind of give you a little update what we're going to go to. So we call this one baseball in numbers, visualizing performance data with R. I gave you the links to download R Studio, or work in the cloud space. Who I am, I'm a finance professor at Xavier University. I started teaching sabermetrics, and what got me going on this, I have one of my best friends in the university is the chairman of the business analytics department. And I said, look, you guys teach stats and you jump from flower petals to this, to that. I said, the way you should teach stats is just something good. Use data like baseball data. And he said, okay, I've got you signed up for the fall. And so here, 8 or 9 years later, I'm teaching a statistics course with baseball data. I love it. We've expanded. We do baseball analytics for the Xavier baseball team. I can dig into that a little bit in the Q&A, but we help the coaches with templates so they can help cut out some of the time when they do their pregame prep We do post-game reports. I could, if there's time, I can show you some of those. So on. So we do, uh, we call it the Xavier Baseball Analytics Team. And for some of you I saw some questions about high school and college. If you can find a way, if you can go to a coach and say, hey, can I work with some of the data? Can I do something that takes something off your plate? If you can free up some of their time, then that is a good way to get involved and start working with the analytics. And there's a lot of things you can do. So we'll talk about that as well. So one of the things that's really cool, SABR now maintains it, but before it was the Laman database. We're going to use the Laman database package in R, which is nice. There's so many cool things I can do with the Laman database package and visualization. And then I've got some TrackMan data in that folder in the chat. It's modified. I had to change the name of the picture and stuff, so you get that. But we'll get an idea on how to plot some of that as well. But like I said, we're going to use the ggplot in R to do some of that. And then, I'd give a shout out, Sean Laman's been maintaining this database for years, but now SABR's taken it over. Again, nice commitment to stuff there. Here's where you can find some of the data, which I posted in the chat. And let's bring up a fresh RStudio and do some coding. So if you want to work along with me, or just I'm going to try to explain it in a way that tell you what I think is going on. But let's build out some graphs. So a couple things, if you've never used R before, one of the first thing you want to do is install some packages. We'll use the tidyverse. An awful lot of people work in the tidyverse environment. You notice I hit type install. It would help if I typed it right. Install packages, tidyverse. And I look down in the console and I see that it's updated. So we're going to install the tidyverse, which gives us a lot of functionality. And then the Laman database. And finally, the other one that I'm going to use today is ggRepel. And ggRepel is a really cool package for allowing us to, again, I've got to put that S in there. Are you guys able to see my screen okay? Is the font big enough? The color right? All right. Okay, good deal. Good deal. I did a little chat research before to find out what background and font size to use in a Zoom call. Not just students using AI, professors too. So I got that going. All right. So I've loaded these three packages, and then one of the things I can do is I can comment those out. Once the next time I come to R, those packages are there. Control-Shift-C will put a pound sign in front of those, and that'll comment those lines out, and I won't have to go through the install packages again. But I do have to remember every time I start a new session in R, I need to load those packages in. So I use the library function to load those packages in that I want to use. So just library. When we install packages, we use the double quotes. When we load them in libraries, we don't need any quotes. Okay. So we'll just do a couple R reminders. Some of you that are veteran R users, we want to remember that R is case sensitive. So a lot of the problems I find are I make it capital one place and lowercase one place. The sensitivity is important. The pound sign gives me comments. Most of the time, I do not use comments well enough, like most programmers. If I was more disciplined and I gave myself more comments It's amazing how much I come back to programs I wrote 6 months later, and if I had more comments, it would help me remember why I did certain things. But maybe you'll be better at that than I am. All right. So what I want to do is let's just do a simple, let's build a simple histogram. And I think this is a great place. Histograms are a great place to start whenever I'm analyzing data. What I want to do is the neat thing about the Laman package is it has all these different tables, and one of the tables is called teams, right? And this just gives us stuff like win-loss record and so on. And so teams, this is built into the Laman data package. I'm going to use my caret hyphen. So notice it's like an arrow. I'm going in. I'm taking this teams table, and I'm going to load it into an object or a data frame that I call teams with a lowercase. So I'm going to use lowercase teams to acknowledge the things I create. The capital teams. This is part of the Laman package. In fact, I can click over here on the right, and I can go down to the Laman package and open it. Yeah, I've got something running here, but we'll look at it in a minute. So I'm going to load the teams data frame. I'm going to load the teams table into a data frame called teams with the lowercase. And it's waiting for something to run here. Let's restart what do I got going here? There we go. So we'll load back in the libraries. Since I restarted R, I've got to do that. I'm going to load this teams table into a data frame I'll call teams, which I can look at over here in my global environment. I can open up that teams table, and I can see that I've got data on all the baseball teams back to 1871. I'm just going to look at something simple. I want to look at home runs. I want to look at home runs hit per team by year. And let's do that since 1950. All right. So I'm going to create another data frame called Teams 50. I'm going to start with teams that I just created. Control Shift M gives me the pipe operator. There's a newer pipe operator that looks like that. I don't use that pipe operator, but if you see the latest version of analyzing baseball data with R, they use that pipe operator. And while I'm talking about it, that book, Analyzing Baseball Data with R, that's something I would recommend to anybody that's interested in learning to program with R. And I would just treat it like a cookbook. I'd start on the first page, prop it open, and start typing the code, trying to replicate what they suggest. It's a great way. It's a great way to learn it. Anyway, okay, so I've got Teams 50, and I'm going to filter for year ID greater than 1949. And I'm going to filter for games greater than 150. So I'm going to filter out like the year 2020 and any of the strike years. So I'm going to get a new data frame that's just a subset of of the whole team's data frame. All right. So now now we've done a little bit of data wrangling. Let's build our graph. All right. So we're going to use ggplot. We're going to use ggplot. And the first thing I feed ggplot is the data set. And I'm going to say data equals teams 50. Once you get used to the syntax, a lot of times I can leave the data equal part out. So if you see other code that doesn't have it, I don't necessarily have to know all the code, or I don't have to include all the code, but this is helpful to know. Then the next big piece of a ggplot is the aesthetic. And the aesthetic is the thing that you want to graph. It's the statistics, the data, the things you want to graph. So AES stands for aesthetic. In this case, the aesthetic that I want to graph is HR. I want to graph team home runs for the season. All right. So I've got the basics of the ggplot. And next step. So the cool thing about ggplot is I use the plus sign to add layers to my graph. So in this case, I've identified the data set I want to use. I've identified the statistic or the data that I want to focus on. So the next step, I would say, let's create a histogram. All right. So ggplot data equals teams 50, aesthetic equals HR plus histogram. All right. And we can hit Control Enter. So, oops, let's get our data. We've got to get our cursor on one of the two lines and say Control Enter. And over here on the right, here is my histogram. Right? And it's like, okay, kind of cool. But the thing that is really cool about ggplot is the amount of customization and specialization I can do, right? So I'm probably not going to show anybody that. I mean, it's kind of interesting. I see, a lot of lumpiness in the center, maybe somewhat like some kind of normal distribution. But let's make this graph shareable, right? And so the way ggplot works, I could just keep using a plus sign and keep adding lines, which is what I generally would do. But I can also use this last plot function. And the last plot function will let me take whatever I've done so far, and start adding on to the ggplot. So the first thing I want to do is add labels, right? So labels in any graph, important thing is to get good labels, titles, etc. on there. So my labels function, let's give it a title. We'll call it Team Home Runs since 1950. Let's give it a subtitle. We'll say modern era seasons with over 150 games. Give it an X label, home runs. And a Y label, we'll say the Y label number of team seasons. Right. So notice I can take my last plot. Now, if I was doing this most of the time, I would get rid of this last plot function and just put my plus sign here and add it. But there are cases, and we'll show some other place where I might want to start. Might want to do a graph one way and then do it another. So the last plot function, or I could put a common way to do this would be create an object called G1 that includes the ggplot and then add things to G1 and print. But we'll do that again. We'll do that again later. So this is definitely a good place to start. Let's see, what else do we want to do? I mean, I'm obviously, while we're here, I'm curious, who are these outliers, right? So while we're at it, let's look at some of these outliers, and let's use our R functionality. Like what were the high numbers and the low numbers? And we can take our team's 50 and filter for home runs greater than 300. And then Control Shift M. Select. Let's look for team ID, year ID, and home runs. So notice down in my console, it shows us that the Minnesota Twins and the Yankees from 2019 had 307. Sorry, the Twins and the Braves had 307. Yankees had 2019. So notice what I did here. I didn't create a new object like we did up here. We created this new object. We put teams with over 150 games since 1949 into a new object. Down here, we didn't, and the results spit out in our console. So we can answer questions that way. Another way we could answer the lowest. What were the lowest? And we could say, let's do teams 50, Control Shift M, and we'll just arrange by home run and Control Shift M, select the same things. And then we can use the head function. So these were the 10 lowest. So the head functions gives me the 10 observations here. So we arrange by home run, select team, year, and so on. So we see Houston in 1979 only had 49 home runs. There were 60 individual players hit more home runs in 1969 than the Astros. So some fun stuff while we're there. But again, I'm not crazy about the histogram. Let's add a little to it. Let's go on up and let's combine our what we've done so far. Let's take what we've done so far. Let's take our ggplot and our titles. So there we go. We've got our ggplot. We've got our titles. I'm just copying the code from above. But this time what I want to do is make it even a little better. I want to say fill. So in the histogram function, I'm going to say fill equals white smoke. So there's a color. Color equals dark gray. And what I'm doing is I'm going to put some color to, I'm going to put some color to the histogram, make it a little more readable. And then I could either use bins, the number of bins that I create, or bin width. Let's do in this case bins 30. And let's go there. So there we go. We're starting to get a little nicer looking graph. Again, we just keep adding and adding and adding. Um, and let's see. I'm just going to add some stuff that I've created. You can find these in my code. Let's add a mean line and a median line. So we're going to add a mean line because we're going to use this V line. And if you can't keep up with me at this point, that's not a problem. It's more an idea to show you, okay, now we've got a distribution where we see all the different bins. We see where the mean is. We see where the median is. We're going to use a GMV line to get those lines in. And then finally, the last step we're going to do is put some text on here. So let's put some text on here. So I'm going to use GM text. And in the spot about 200, X equals 250 and Y equals about 100, I'm going to put in this label. The mean of the team season home runs is, and then I'm going to calculate the home runs, right? So now we've got a graph that's shareable, right? It's really cool. We could keep going. We could put the median online. One of the things that I like to do a lot when we prep coaches for games is we'll take a statistic like first pitch swing. If we're looking at hitters, we'll take first pitch swing. We'll create a distribution. You know, what were guys' first pitch swing last year? We'll create the distribution and then we'll put a point on the graph at each point where their guy ranks in relation to the overall distribution. So we can put the number in perspective. Is he really an outlier, or is he more kind of center of the pack? All right. So there's a cool graph. Then you say, well, what do I want to do with these things, right? Well, a couple different things, and we'll show a couple different ways. I can export, I can save as an image, right? In this case, I'm going to say it'll prompt me for a name. Our plot seems fine. I'll go to the directory and pick the directory that I gave you. And I've found a lot of times it helps to bump the aspect ratio up, make them a little bigger. But let's go ahead and save that. And then if I've got a PowerPoint or something that I'm working with, I just insert that image into the PowerPoint or so on. All right, so that's a simple GG plot, a simple histogram that's not so simple when I get done, but is actually a very nice visual that I can share with somebody. I can look like I'm really sharp. Let's shift gears a little bit. And I'm going to go ahead and skip down. I'm going to do a quick XY scatter plot. And then we're going to jump into some pitching data. All right. So let's use the Laman data to plot pitching strikeouts versus ERA. So start from scratch here. We're going to I'm going to create a data frame called lowercase pitching by feeding it the Laman pitching data frame. And And then while I'm at it, I'm going to use the people data frame so I can get some names matched up with my data. So if I look at pitching, it'll have pitching statistics, season pitching statistics for guys, and people has the player ID, and then I can match up with the players' names, all kinds of good stuff I can match up with. So I've got pitching and people. And what I want to do is I'm going to take pitching. I'm going to overwrite it. Control Shift M for my pipe operator, and I'm going to left join it with people. And I'm going to create a new variable. I'm going to use the mutate function to create a new variable called name. And we'll see why here in a minute. All right, so now I've got a pitching data frame with players' names. So let's go ahead and do our graph. So we're going to do ggplot. ggplot, the data we want to use is, and let's do this. We'll do one more. Let's do one more. We'll do pitching 2020s. We'll start with pitching, and we'll filter for year ID greater than 2024 and IP out greater than 224. So that'll give me guys that have pitched at least 75 innings in 2025. And I need IP out. There we go. All right, so let's do our graph. So ggplot, the data we want to use is pitching 2020s. The aesthetic, X is equal to strikeouts. And Y is equal to ERA. And we want to do a simple, we want to call it GM point. So GM point gives me an XY scatter plot, right? So here's my graph. It gives me each guy's season strikeouts versus ERA. And so some fun stuff we can do. We can put in a smoothing line. Is there a trend between so GM smooth, I'll put a trend line in there for me. And notice it'll put some confidence intervals around it. So a lot of wide confidence interval in the extremes. We can use, I like this, the typical GM smooth command, but we can also, if we're wedded to linear models, we can put a we can put a line in there, an LM, right? So those are some things we can do. Here's where it really comes in. We use ggRepel, and what I'm going to do next, I'm going to use the ggRepel function to add a GM text repel. And in GM text repel, I need to give it the data. So what I'm going to do is I'm going to give, well, I'm not going to do it yet. I'm just going to give it all. Let me see, data equals pitching 2020s. And then the aesthetic, I want X is equal to strikeout, Y equal to ERA, what we've done so far. And then we'll say label equals name. And in fact, let's just make it simple. Let's get rid of the data because it's going to inherit the data from above. So there we go. So I just took my XY scatter plot and this GG repel will put every guy's name on here, right? So now I've got a graph that the GG repel is going to put a player's name. And notice the little repel, the little lines there. It's showing us where each guy fits on the graph, right? Now, part of it, this is kind of cool, but it's a little bit overwhelming with so many names on here. So what I might want to do is add in a data line, and we'll say data equals subset, and let's take pitching 2020s and strikeouts greater than 200, or so that the vertical line is an or strikeouts less than 60, ERA greater than 6, and ERA less than 2.5. Let's see. Well, it doesn't look like I eliminated anybody, but oh, I think it's the plus sign I've still got there. Let's try it again. Uh, well, let's take the whole thing in that worked at one point. There we go. So by using the subset, I get a little fewer points, So just depending on the case you're trying to make, what you're trying to do. So that's an X-way scatter plot. In my code, I've got a good column graph, but I wanted to get a chance to present. Let's use some TrackMan data because I think that's where I think the TrackMan data, and a lot of teams have TrackMan data. Some of them don't know what to do with it. Whether you get something out of the actual graphing or not, you might get something out of the discussion of this next graph. So what I want to do, and I've got a file with some TrackMan data, and I'm going to post that. Yeah, that's in the drive I gave you, but there's some code that'll get you that file. So what I'm going to do, I'm going to take that URL and I'm going to use a read CSV to load that into. Oops. I'm going to load that into a file called PitchStat. So if you've never seen TrackMan data before, it looks kind of like this. We get pitch number. This is one of our guys last weekend or two. It gives the pitch plate appearance of the inning, pitch number. notice we got 175 different columns for every pitch during the game, right? And what we're going to do first is we're going to plot pitch movement. So pitch movement's a pretty common chart. We'll explain it real quick here with the baseball, right? So what we're trying to do with pitch movement is we're trying to describe how the ball moves if the ball left my hand, spun, just straight back spin, it would hit the origin, right? But most guys have a little bit of they have the ball out to the side, they're going to release and it's going to spin up, right? Or if they throw a curveball, it's going to tumble away. Or if it's a slider, it's going to move across. So what we're going to do is use the data in here to create a pitch movement chart, which is used very much in bullpen sessions and trying to understand pitch movement and what people are doing. So a couple housekeeping things. We're going to use these labels later. So I'm just going to copy these in here. These aren't overly important to what we're going to do at first, but I'm going to put those in. And let's get into the graph. So the graph, I'm going to ggplot. The data I'm going to use is pitch stat, and I'm not going to retype pitch stat. The aesthetic I'm plotting, x-axis is horse break. This tells us how much the ball moves right to left. And y equals induced vert break. Those are the variable names. And I'm also going to put in a color for the tagged pitch types so we can see. So say color equals factor. So if I create a factor, I'm basically just identifying it as a type of data. Right. So thank you. Can't see my, there we go. See my screen now? All right. So I added some labels. Let's get back to the important part of the plot. Using this pitch data as my data. The aesthetic I'm using is horse break, induced vert break, and I'm going to use color to identify the pitch types. And I'm going to just start with a very simple GM point, so an XY scatter plot. So if we look at our guy's outing, here's your, if we shoot a bullet out of a gun, it goes right here to 0, 0, right? And don't confuse this with the strike zone because we've got other data for that. Okay. We shoot it out of a gun, goes here, 0, 0. The fastball spin and head up to the upper right. This guy's a righty, right? Sliders move vertical, curveballs vertical and down, right? Now, understand these actually, since we're induced vertical break, we're assuming away gravity. We're assuming if gravity didn't exist, if we threw this pitch on the moon, here's where the ball would end up. In reality, they all fall because of gravity. This falls less because of the spin on the ball. So that's what we need to understand on that, right? So let's finish. Let's add more to the graph, right? Because that 0, 0 point is very important. So we'll add a GMH line where the y-intercept is equal to 0. The size is equal to 1. And we'll add a GM vertical line where the x-intercept is equal to 0. So now we've got a little better visual on where the ball's going. What I'm going to do is I'm going to put this in object. I'm going to put this in an object called G1. And then I'm going to take G1 and add, um, I don't like the colors that default here, right? So we like to see the colors always the same. So we've used this scale color manual, and we've defined a fastball as dark red, a sinker as coral, and so on, right? So I'm going to copy that in, and I'm just going to say G1 plus colors, right? Or what I can do first, let's just redo. I gotta run that one. G1, run the colors. So one of the things we have these colors. I have these colors in a file. I have colors in a file. I run this. In any report we do, we're using these particular colors, and I'm missing a couple parens here. So now I've got. Oh, I have the anyway. I am. Let's see. Let's do a couple more things. Let's add in some labels. Um, our guys like to know how hard they threw in an outing. Some things like that. So let's add some more layers to this. I had created the labels up here for max velocity for the outing and so on. So here's more, getting a little closer. One of the other things we like to put on here is on these is percent of the pitches that were in the zone. So we'll put another label on for that. But you can start to see in a one-page graph, we can see a lot about what was going on. This doesn't really look like a slider. This looks more like a sweeper or something that was some of these I'm guessing were tagged and were probably change ups because they don't move as far. But anyway, you can start to see that we can get an awful lot of valuable data on one graph that is a very nice visual for a guy to see. How his outing went. Is he making progress on the things he want, and so on. A couple more things before I open it up for questions. I showed that we can export these things this way. Another good way to save things that I tend to use a lot is I'll set the working directory to where I want to save the graph. So in this case, I've got this dry. There's some graphs, right? And so what I'll do is I'll create I'll use the PDF function. I'll say movement, or sorry, need it in quotes. Movement graph dot PDF. Once I run that PDF command, everything I do from there, every graph I create after that is going to go into this file called movement graph. So I'm going to run it until I get to the dev.off command. So the dev.off command ends my PDF file, right? And so then I can look it up somewhere, and that movement graph.pdf will be in my file. let's see. I should probably start opening it up for questions. Those are some of the graphs we do. Let me show you quick a strike zone outing we do, or some of the other graphs we do. I'll start with this one. This is what I like to do after games where we can see this is where our hits went. Our field's a little smaller than some other fields, so we put I've got our fence I've got our fence on here, and I've got TD Ameritrade, where the College World Series. Just you kind of see a visual, kind of I think there's the website Wooded Dong, that kind of idea. These are hits and these are outs, and these are all done with ggplot. Another good one that is a lot harder than at first blush would be strike zone reports. They give you where the ball, and there's obviously going to be a lot more interest in this year because of the automated strike zone and the ABS challenges. But let me just pop up one of those for you. Right. So this is a zone report where we're plotting the pitch location, height, and side, and then we build in the zone. And in the PDF, or I'm sorry, the R program that I provided for you shows how to put in some of the rectangles and so on. I don't think I have the plate in there, but you've got your legal strike zone, which gets a little bit challenging top and bottom. You've got your ball width on each side, and then we add in we add another I think 3 or 4 inches we call competitive pitches. So we can just say, how some of these pitches aren't really competitive. We want to know, what's something a batter might actually swing at. And so nothing that hard about the graph. It's just what you settle in for your dimensions of the strike zone. Here's your legal strike zone. But you think about any of these balls that come in this shadow zone, a ball width. I mean, those could definitely be nicking the plate. Umpires say they like to call at least 60% of those strikes, and then of course we like to see. One of the things in talking to umpires they'll do is they'll go back and say, well, let's look at this pitch. It's possible that it went into the zone, but when it actually, or went into the zone after it crossed the TrackMan line or whatever. Anyway, let me open it up for questions. There's tons of good data out there. I think if you can really focus on making visualizations and trying to present your analysis in a way. I think people are such visual learners. I think it's playing with ggplot and getting good with it. At first, it looks intimidating, but then you realize how much power you have and how you can keep adding layers and layers. And Chat is really good at debugging, or Gemini is probably the one, or Stack Exchange. But let me open up for questions. Yeah, Michael, I have. The question is, can I share the strike zone and the field plots? What I'll do is I'll put some of these. I'll put some code snippets in that folder I shared out with you when we hang up here, and we'll go from there. Um, so Eric asks, how in depth do the statistical analysis? I don't know. We don't get that in depth. I mean, all the resources, like Um, uh, we use a lot of 643 charts data, and it'll give us WOBA and weighted runs created and FIP and Sierra and stuff. Um, I don't think our coaches get overly focused on those. I think they tend to like to watch a lot of video and get a sense of what guys are doing. They like to have the basic stats to help inform their viewing. I don't think we get that sophisticated. Um, Bryce asks, is grad school essential for building skills in baseball analytics? I don't think grad school is. I think if you could do most of the stuff in analyzing baseball data with R, I think you'd have a really good skill set that a lot of people would like. Um, so biggest challenges in helping players. To me, I think it was kind of this understanding that you got to find a way to show stuff to them graphically. I mean, these guys are really visual learners, and the more the GG plot's your tool, I think. Um, Eric, thanks, or Evan, thanks about being easier. Um, I would really encourage a lot of you to do the SABR Analytics certificate. That's kind of the approach there. Um, I think videos like this are really good when you can pause them, try something, come back, pause them, right? So Saber has a bunch of my old videos, a bunch of I'll go watch. You'll see Shauna this afternoon, and I mean, some of the people they've had on here are just fantastic. And if you can dig up some of their old videos, those are a great way. Those are a great way to learn. Evan, your point about the rule book is three-dimensional. TrackMan is two-dimensional, so you make a really good point. I mean, I don't know that we're going to ABS Challenge in college baseball anytime soon because I don't think we're getting to that 3D level. Um, Britain says open source resource baseball data that's open. Llama's fantastic. RetroSheet. So just retrosheet.org. The play-by-play data there is fantastic, and analyzing baseball data with R will give you some programs where you can do some really interesting stuff with that. So I'd say Laman, RetroSheet. Get a hold of a TrackMan file. You've got one that I posted. There's some fun stuff to do with that. Denny asks why you would use Python over R. I'm a finance professor. I only know how to do R, so I can't answer that one. I've tried to teach myself Python, but every time I've got something I really need to get done, I figure out a way to get it in R. So again, Winston, I would say analyzing baseball with data with R and the SABR Analytics certificate, those are good. Ethan, in terms of Rapsodo data, you're going to do it very similar to what we just did with the TrackMan data. So Rapsodo data, TrackMan data, they're both very similar. I know there are some differences in how they read and so on. But the programming I gave you should work with Rapsodo. In fact, it does because I work with a high school team and use their Rapsodo data with pretty much the same. And I don't have an opinion on Hawkeye data because I don't have any of it. But fantastic questions. I'm pretty sure I'm out of time, Scott. I don't know where all the time went.
You did great, Dave. You
Thanks. So
could have kept
fun.
going. And I'll send you your check for your free plugs of the analytics certification courses. So thank you very much.
Well, you guys are, I mean, I love how you guys have embraced the students. And I mean, it's definitely, I love the direction Saber's headed with that. It's fantastic.
Well, we've got great colleagues like yourself that volunteer their time to come talk to our students, and we really appreciate that. So another great presentation. Thank you so much, Dave.